I'm Anil Kumar, and in this video we will learn how to solve absolute inequality, especially when we are dealing with greater than situation. The question here is solve each of the following: absolute value of x minus 1 greater than or equal to 1, and the second one is absolute value of 2x minus 3 greater than 5. Now I will show you how to solve such inequalities using different methods. Now first one here, which is absolute value of x minus 1 greater than or equal to 1, we could think about the function on a number line where absolute x minus 1 will be absolute function shifted 1 unit to the right. So basically the function absolute x is kind of like this right here, right? Now we are saying that this is absolute x minus 1, so that means it has shifted 1 unit to the right? So that is the vertex of the absolute function. Now what we really want is that this function should be greater than equal to 1. That is to say that we are looking for values on the number line which are horizontally away by at least 1 unit. So that means from this point on the vertex, 1 unit to the right will be a position 2 and 1 unit to the left will be a position 0, right? So when we say away, I mean greater than equal to, that means away, outside, right? So that becomes the solution. Do you understand the logic? So we get our solution like this. That is to say, the solution should be x is less than equal to 0 or x is greater than equal to 2. Why equal to? Since the inequality is including that point, correct? So that becomes the solution, right? So at times, if you logically think about it, it is as simple as that. Now another way, this could be method 1 for us. Another way to do the same thing is, let's use method 2. When we are saying absolute value of x minus 1 is greater than 1, greater than equal to, in that case we want to say that x minus 1 is greater than equal to 1 or x minus 1 is less than equals to minus 1. You get the idea, right? So it's away, so it's going outside. So it is, this absolute function could be written as x minus 1 greater than equal to 1 or x minus 1 less than equals to minus 1. In either case, if this is a negative number greater than 1, I mean less than 1, then the magnitude absolute value will be greater than equal to 1. That is also by the definition, right? So in this case, now let us solve these two inequalities. Now when you solve them, what do you get? Let's take this 1 on the other side. So get x is less than equals to minus 1 plus 1, x is less than equals to 0. You get the same answer. Do you see that? And on the right side, x is greater than equals to 1, taking 1 on the right side, plus 1, so x is greater than equals to 2. So what you get is exactly what we got from method 1, right? So that is how it could be solved. So I've used two different methods to show you how to solve such an inequality. Now let me teach you another method to solve the second inequality. Now this time we will actually define the absolute function as a piecewise function. So the inequality is 2x minus 3 is greater than 5. Let us define what is 2x minus 3 absolute value. Now it really means that it should be 2x minus 3 when 2x minus 3 is greater than equal to 0, and it is negative of 2x minus 3 when 2x minus 3 is less than 0. That is how you define the absolute function as a piecewise function, correct? Now let me rewrite this as 2x minus 3 when, solve for x here, when x is greater than equals to, taking 3 on this side, dividing by 2, right? And minus, let me open the bracket, minus 2x plus 3 when x is less than 3 by 2. So it could be defined like this. Now it really means, let me draw a line here just to differentiate. So we are doing this particular question now. It really means that we have to solve two different inequalities. One in the interval when x is less than 3 by 2, or 1.5, right, when x is less than 3 by 2, and the other when x is greater than 3 by 2. So in these intervals we'll have kind of different equations, right, slightly different. We'll use the piecewise definition of the absolute function now. So we have absolute 2x minus 3 equals to 2x minus 3 when x is greater than or equals to 3 by 2. So on the right side I should write, instead of absolute function, 2x minus 3 greater than 5. And on the left side, when x is less than 3 by 2, I need to replace the absolute function with minus 2x plus 3. You get the idea, right? And the inequality is greater than 5. So these are the two equations to solve. Now let's solve them. So bringing 3 to the right side, we get minus 2x is greater than 5 minus 3, or x is, now when I divide by minus 2, the sign changes. This is very important. The sign has to flip when you divide by minus 2. Now 5 minus 3 is 2, divide by minus 2, or x is less than minus 1. So that is what you get on the left side when x is less than 3 by 2. And on the right side, let me take 3 on the other side, we get 2x is greater than 5 plus 3, which is 8, and x is greater than 8 divided by 2, or x is greater than 4. So that becomes the solution. Now on a number line, I can always show this solution as, let me push this page a bit. Okay, now so what we are saying here is, on a number line, our solution is, let us say this is 3 by 2 or 1.5, let me write. Okay, in that case x is less than minus 1, so minus 1, this is 0, let us say, and let's say this is minus 1. X is less than minus 1, or x is greater than 4, kind of like this. Do you see that? So that is how I can show the solution on a number line, right? So my answer is x is less than minus 1 union x is greater than 4, right? So that is how we could write down our answer. I hope these methods help you to understand how to solve inequalities. Now I would like you to solve this particular question using these techniques, and solve the first question using the technique which we have learned just now. We already learned how to solve inequalities using graphs, so you can use that method also. There will be a fourth method to solve inequalities. I hope this exercise really helps you to bring all the concepts together and help you to solve such questions. I'm Anil Kumar. You can subscribe to my videos and learn a lot. Thank you and all the best.